Bismillahirrahmanirrahim. In this lecture, I am solving problem 2.2 from the book Power Plant Technology by Al-Wakil. So, the statement of the problem is in a non-ideal Rankine cycle, steam enters the turbine at 14 megapascal and 500 degrees centigrade with a mass flow rate of 150 kilogram per second. The condenser pressure is 8 kilopascal. This cycle has a turbine polytropic efficiency of 88% and a pump polytropic efficiency of 80%. Additionally, a total pressure drop of 6 bar occur in the feedwater lines and steam generator. Calculate the net cycle power in megawatt and the cycle efficiency. So, as this is Rankine cycle, non-ideal Rankine cycle. So, to understand the idea of the problem, first we have to draw the Rankine cycle. So, here I am trying to draw a clear non-ideal Rankine cycle on TS diagram, where T is in degree centigrade and entropy is in kilojoule per kilogram per Kelvin. This is the saturation curve. In thermodynamics, it is clear to you from thermodynamics knowledge that this is saturated liquid line, this is saturated vapor line, this is subcooled region, this region is wet region or mixed region of liquid and vapor, and this region is a superheated region. So, to draw a Rankine cycle on a TS diagram, this is the turbine. First I am drawing turbine. This is point 1 and this is point 2s. 2s mean ideal, in ideal case, and in real case this is something like this. This is point 2. So from 1 to 2, this is turbine, and turbine give us work output. This is turbine, and turbine give us work output. Similarly, from 1 to 4, this is point 1 is in superheated region. So this is point 1, and that I name this point is point B, and this is point 4. Means that from point 4 to 1, from point 4 to 1, this is steam generator, and steam generated heat is supplied to the system. And from 2 to 3, this is from 2 to 3, this is condenser. From 2 to 3, this is point 3, and this is condenser. In condenser, heat is rejected, and from 3 to 4, this is point 4 is ideal case. In real case, this will be something like curve. This is 4. So from 3 to 4, this is pump work. pump, and pump work input to the system. So and pump there is work input to the system, and steam generator from 4 to 1 steam is produced and heat is supplied to the system. From 1 to 2 this is turbine work, and in turbine work output of the system. And from 2 to 3 this is condenser, and in condenser heat is rejected to the system. So in the given data, steam enters the turbine at 14 megapascal and 1500 degrees centigrade. This is the entrance. Point 1 is the entrance of turbine. From 1 to 2 this is turbine. So point 1 is the entrance of the turbine. So P1 at the entrance of the turbine, this is point 1. So P1 is equal to 14 megapascal and T1 is equal to 1500 degrees centigrade. Now here, and mass flow rate m dot is equal to 150, m dot is equal to 150 mass flow rate kilogram per second. Similarly, the condenser pressure is 8 kilopascal. This is condenser pressure, and condenser pressure is constant. This is, and condenser pressure is a constant. So at this, from saturated liquid line to saturated vapor is a straight line, and here pressure is constant. So P2 is equal to P3 is equal to 8 kilopascal, and in megapascal divided by 1000, so this will be equal to 0.008 megapascal. Similarly, the cycle has a turbine polytropic efficiency of 88% and pump polytropic efficiency of 80%. So efficiency of turbine, polytropic efficiency of turbine is 88%. Efficiency of 88% mean 88 divided by 100, which is equal to 0.88. Similarly, polytropic efficiency of pump, this is pump, efficiency of pump is equal to 80%, which is equal to 80 divided by 100, 0.8. Now, additionally, a total pressure drop of 6 bar occurs in the feedwater line and steam generator. So here pressure drop and in steam generator and feedwater line in the condenser. Here from the pump, this is the point 4 is the end of the pump. So from the end of the pump to in the steam generator, and similarly in the condenser, total pressure drop is 0.6 megapascal. Pressure drop is 0.6 megapascal. So and in the pump, the main work of the pump is to increase the pressure. So in the pump this is 0.4. 0.4 is the end of the pump. So 0.4 will be P1 plus pressure drop. It means that the work of the pump is to increase the pressure. So P1 is given to us is 14 megapascal and pressure drop is 0.6 megapascal, which is equal to 14.6 megapascal. P4 is equal to 14.6 megapascal, and required is to find net cycle power in megawatt and the net cycle efficiency. Number 1, find net power in megawatt and cyclic efficiency, net cyclic efficiency. So to find net power and net cycle efficiency, we have to understand some basics formulas for finding the efficiency and the power input. So we know that the cyclic efficiency is equal to cyclic efficiency is equal to output divided by input. So in this case, in Rankine cycle, input is the heat supplied in steam generator and net work. Output divided by, so our output is net work done. Our main output is the net work done, and this net work done is equal to work output minus work input. So work output is the work in turbine and work input is the work in the pump divided by heat supplied in the steam generator. Similarly, power net power is equal to mass flow rate multiplied by network, and network is equal to work of turbine minus work of pump. So I mean that first we, for cyclic efficiency and for network output, first we have to find work of turbine, work of pump, heat supplied in the steam generator. So then we can easily find cyclic efficiency and net power output. So for work done we will use formula, for pump work we will use different formulas, and for heat supplied we will use formula and explain at each and every stage. So we will use this Rankine cycle, and these formula different enthalpies are involved. So we will have to find enthalpy at point 1, at point 2 and at point 3 and at point 4. Similarly, we have to find entropy at different points, and similarly we have to find specific volume in different points, and that put these values in different formula, and we will have to find work of pump, work of turbine, then from these two values we will find network output, and then we can easily find our required value. So now I have to start the solution. So first I am trying to start from point 1. Point 1 is clear that this is in the superheated region, and it is clear from the given data, because at P1 is equal to 14 megapascal and T1, this T1 is 1500 degrees centigrade. This is superheated temperature at 14 megapascal, and I can uh, clarify this from the steam table. So at P1 is equal to 14 megapascal from saturated steam table. Saturation pressure is equal to, this is given in the table, this is the table, and this is the pressure, this is pressure, and this is temperature, saturation temperature. So this is 14, pressure in megapascal, this unit is megapascal, and pressure is 14 megapascal. At 14 megapascal, saturation temperature is 336.67, 336.67, 336.67 degrees centigrade, but the temperature given to us is 1500 degrees centigrade. As T is equal to 500 degrees centigrade greater than saturation temperature. So point 1 is in superheated region. So to find H1 and S1 we will use superheated steam table. So from superheated steam table, at pressure is equal to 14 megapascal and temperature T1 is equal to 500 degrees centigrade. Find H1 and S1. So steam table is available here, superheated steam table. So this is superheated steam table, and this is pressure in megapascal. This is pressure in megapascal, and this is temperature in degree centigrade. This is 500 degrees centigrade. So this is 500 degrees centigrade, and this pressure is 14, and this is specific volume, this is enthalpy, and this is entropy. So at 500 degrees centigrade and in front of 14 megapascal, these values are for enthalpy, specific volume, and specific internal energy. So here at 1500 degree centigrade and 14 megapascal, H, this is H, this is the value of H, and this below value is the value for S. So H is equal to 3324.1 kilojoule per kg, and entropy is 6.3931 kilojoule per kilogram per Kelvin. So from superheated steam table, H1 is equal to 3324.1 kilojoule per kilogram, and entropy is 6.3931 kilojoule per kilogram per Kelvin. Now we have to find the enthalpy, entropy, and specific volume 8.3, and it is clear from this is 0.3, this is 0.3, and 0.3 we know that H is equal to HF is because this is saturated liquid line. S is equal to SF and V is equal to VF. So we can easily find enthalpy, entropy, and specific volume. So for condenser pressure is basically P3, and P2 is equal to P3 is equal to 8 kilopascal and megapascal divided by 1000. So this is 0.008 megapascal. So at this pressure, from saturated steam table, H3 is equal to HF, which is equal to S3 is equal to SF, and V3 is equal to VF, and these values are given in saturated steam table. So this is saturated steam table, and this pressure is in megapascal, and this is 0.008 megapascal. This is 0.0. So at 0.08 megapascal, VF, this is VF. VL mean volume of liquid, or we can use VF term. So VF is at 0.00 pascal, 0.001085 meter cube per kg. This is the unit of volume. And HF, HL or HF is 173.85, and similarly SF is 0.5925. So from saturated steam table, at pressure of 0.008 megapascal, H3 is equal to HF is equal to 173.85 kilojoule per kg, and S3 is equal to SF is equal to 0.5925 kilojoule per kilogram per Kelvin, and V3 is equal to VF is equal to 0.001085 meter cube per kg. Now these are the properties which we are needed for the different formulas, and at 0.3. Now at the start of the condenser we have to find H2S and H2. So now we have to find H2 because H2 is used in the formula for the work of the turbine. So if we are finding work for the turbine, so for work of the for turbine we we have to find H2. So for H2, uh, first we find X2S from the formula S2S. Difference between S2 and S2S is S2 is the uh, actual entropy at point 2 and S2 is the ideal entropy at point 2. So S2S formula is SF plus X2S into SG minus SF. We have to find SF and SG from this steam table. Similarly, to find H2S, we have the formula H2S is equal to HF plus X2S into Hg minus HF. So HF and Hg is already given to us because for 2 and for 3 property are same. So because pressure is same at both properties, so we will find H2 HF and SF at pressure 0.008 megapascal because at point 2 and point 3 pressure is constant. Here if we check this, here already explained this point that pressure is constant on this line. So find HF, Hg, SF, Sg from steam table. So from saturated steam table at pressure is equal to 0.008 megapascal. Find HF, Hg, SF and Sg. So again this is 0.08 and HF, this is HF, this is Hg, this is SF and this is Sg. So all values we can easily find from the steam table. So HF is equal to 173.85 kilojoule per kg. Hg is equal to 2576.2 kilojoule per kg. Similarly, SF is equal to 0.5925 kilojoule per kilogram per Kelvin. Sg is equal to 8.2274 kilojoule per kg. Now use the above formula and find H2S, and then with the help of H2S we will find H2. So with help of now we know that H2S is equal to SF plus X2S Sg minus SF. So rearrange this equation and find X2S, which is equal to S2S minus SF divided by Sg minus SF, which is equal to S2S. S2S is equal to S1. S2S is equal to S1 from Rankine cycle. From Rankine cycle. And we can check this in Rankine. This is S1, this is straight line, this is S1, this is entropy line, so this is constant entropy line. It means that S1 and S2S are equal, and S1 is equal to already found this value as 6.3931. S1 is equal to S2S is equal to 6.3931 kilojoule per kilogram per Kelvin. So putting values here, so S2S is equal to S1, which is 6.3931 kilojoule per kilogram per Kelvin. SF is equal to 0.5925. Similarly, Sg is 8.2274 and SF is 0.5925. And unit are same, they will be cancelled. Kilojoule per kilogram per Kelvin, kilojoule per kilogram per Kelvin will be cancelled. So simplify this and find X2S, which is equal to 0.7597. Now we can easily find H2S with the help of formula. H2S is equal to HF plus X2S into Hg minus HF. Putting values in this formula, HF is equal to 173.85 kilojoule per kilogram plus X2S is 0.7597 Hg minus HF. Hg is equal to 2576.2 minus 173.85. So simplify this and find H2S, which is equal to 1998.91 kilojoule per kilogram. And with the help of H2S, we will find H2. So for H2, we know that efficiency of turbine is equal to, this is formula from the book, H1 minus H2 divided by H1 minus H2S. So rearrange this equation and find H2. So if I rearrange this equation, this will be equal to H2 is equal to H1 minus turbine efficiency and to H1 minus H2S. Putting values in this equation and find H2. So H2 is equal to, H1 is 3324.1 kilojoule per kg. Turbine efficiency is given to us is 88% or 0.88. 3324.1 minus 1998.91 kilojoule per kilogram. So simplify this and find H2, which is equal to 2157.93 kilojoule per kilogram. This is H2. Now we can easily find work of turbine. Work of turbine is equal to H1 minus H2. This is turbine and the TS diagram 1 to 2. So H1 minus H2 is work of turbine, work output, and turbine work is work output. So work of turbine is equal to H1 minus H2. H1 is equal to 3324.1 minus H2 is 2157.93 kilojoule per kg. So work of turbine is equal to 1167.17 kilojoule per kg. Now we have to find work of pump. So there are two works. One is actual work of pump and second is theoretical work of the pump. So here pump efficiency, as we know that pump efficiency from the book formula is equal to H4S minus H3 divided by H4 minus H3, and this H4 minus H3 is basically work of pump, ideal work of pump, and H4 minus H3 is actual work of pump, and this is clear from the TS diagram, Rankine cycle. This is H4 minus H3 is basically actual work, and H4S minus H3, this is pump. So H4 minus H3 is actual work input, and H4S minus H3 is ideal work. So this is WPS divided by WPA, and I can write this in other form. Pump efficiency WPS, basically this is work, and work is PV, pressure into volume. So there is change in pressure in pump. In pump we know that pressure increases from 14 megapascal, pressure increases from 0.008 megapascal to 14.6 here, and the work of pump is to increase the pressure. So P2 is equal to P3 is equal to 0.008 megapascal, and here in the pump in work is 14.6 megapascal. So the main objective of the pump is to increase the pressure from 0.008 megapascal to 14.6. So work of pump, ideal work of pump is equal to del phi into V3, change in pressure into V3 divided by actual work of pump. So here we will have to find actual work of pump. So rearrange this equation, and actual work of pump is equal to del phi into V3 divided by pump efficiency. So W phi into A is equal to change in pressure means from 0.008 megapascal to 14.6 megapascal. It means that 14.6 minus 0.00, this is change in pressure in the pump. And V3, already found V3 from the steam table, 0.00, this value is 0.001085, 0.001085 divided by, and unit is meter cube per kg, divided by pump efficiency is given to us as 0.8. So simplify this value and find the actual work of pump. So 14.6 minus 0.008 is equal to 14.592. I can write megapascal as mega is equal to 10.3 kilo or 10.6. So I can write this as 10.3 thousand and kilo. It means that 1000 multiplied by kilo is equal to mega, and I can write Pascal as Newton per square meter multiplied by 0.001085 meter cube per kg, and this is 0.8. So this square meter will be cancelled with 2 square meter kilogram, and this will be equal to Newton meter is equal to joule, and this is kilojoule per kg. So actual work of pump is equal to, simplify this value, so actual work of pump is equal to 18.39 kilojoule per kilogram. Newton meter is joule, and this is kilogram, and this is kilo. And if I simplify these, so this is 18.39. Now we can also find ideal work of the pump. So pump efficiency is equal to WPS and WPA. WP is actual work and WPS is ideal. So WPS is equal to WPA into pump efficiency. So WPS is equal to, pump efficiency is 0.80 and WPA is 18.39 kilojoule per kg. So this is equal to 14.71 kilojoule per kg. Now we can find H4 with the help of this. We can easily find. So from this formula, we know that actual work of pump is H4 minus H3. Actual work of pump is equal to H4 minus H3. H3 is already found by us, and WP is already found by us. So we can easily find H4. So actual work of pump is equal to H4 minus H3. So it means that H4 is equal to W actual work of pump plus H3. Actual work of pump is 18.39 kilojoule per kg and H3 is 173.85 kilojoule per kg. So H4 is equal to 192.24 kilojoule per kg. Now we can easily find work of turbine network. So we know that network is equal to work of turbine minus actual work of the pump. Actual work of the pump. So ideal work of the pump. So net work is equal to work of turbine is 1166.17 kilojoule per kg, and work of pump is 14.71 kilojoule per kg. So net work is equal to 1151.46 kilojoule per kg. So now net power in megapascal. Now we can easily find net power in megawatt. So net power is equal to m dot mass flow rate into net work. So mass flow rate is equal to 150 given to us kilogram per second, and net work is 1151.46 kilojoule per kg. So this kilogram will be cancelled with this kilogram. So power net is equal to 150 multiplied by 1151.46 is equal to 172,719, and this is kilowatt. Joule per second is watt. Kilowatt. Convert kilowatt into megawatt, divide by 1000. So P net is equal to 172,719 kilowatt. Sorry, this is megawatt, and per megawatt divided by 1000. So net power, which is the required value, is equal to 172.719 megawatt. And cyclic efficiency, this is first, and second, find cyclic efficiency. So cyclic efficiency is equal to output divided by input. Output is network and input is Qn. So to find Qn from Rankine cycle, Qn heat supplied in the generator, which is equal to H1 minus H4. If we check the Rankine cycle, so here heat is supplied from 1.1 to 4. From 4 to 1, this is the steam generator. So H1 minus H4 is the heat supplied in the steam generator. So Qn is H1 minus H4. So Qn is equal to H1 is equal to 3324.1 and H4 is 192.24 kilojoule per kg. So Qn is equal to 3131.86 kilojoule per kg. Now cyclic efficiency is equal to output mean network divided by Qn. Network is equal to 11 multiplied by 100%, 1151.46 divided by 3131.86 multiplied by 100%. So cyclic efficiency, simplify this. So cyclic efficiency is equal to 36.76%. And this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.